Okay, we're going to go over a very small concept right now. So the title of this is going to be non-disjunction. And this is going to be when there are mistakes that occur in meiosis. So non-disjunction, what does this word mean? It means not coming apart. So we're going to talk about how the chromosomes don't come apart, and we get things called trisomies and monosomies as a result. Not coming apart. So there's two types of non-disjunction. So I'm going to go like this, separate these two parts of my paper. I'm going to label this up here, non-disjunction in meiosis, part 1. All right, so I'm going to keep this simple. Go ahead and draw your testicle seminiferous tubule cell that spits out sperm, or this would be an egg cell producing cell inside of the ovaries. So we are going to have, let's skip straight to after interphase. We'll have a replicated maternal chromosome, and we'll have a replicated paternal chromosome right here. So there we go. We have our tetrad, homologous chromosomes, and they're supposed to split down the middle. Similar to what I taught you guys. Yes, last lesson, split down the middle. And they're supposed to distribute into 2 cells. But something's going to cause them not to come apart. So instead of coming apart like they're supposed to, they do non-disjunction, which means they do not disjoin from each other. So let's see. These two are going to move over here together instead of the pink one going here and the blue one going here. So let's draw that over here. And then over here, there is nothing. Okay, so let's do the easy side first. There's nothing here. Well, there is something, but not for this chromosome set. This would just be like chromosome pair number 21, okay? This would just be one pair of chromosomes missing in these particular egg cells that are produced. But over here, the result would be a split down the middle right here. So this side would get to these maternal, this side over here would get to, like, well, who cares? Well, that looks right, but it's not right after fertilization. So let's see. Let's say we have our sperm come in, and the sperm is correct. So when this egg plus this sperm meet, instead of having 2 chromatids like they're supposed to, if this were in a normal situation, you just have 1, there are now 3 chromatids. This is going to create something called a trisomy, where you have 3 chromatids instead of 2. And the same thing's going to happen over there. This sperm's going to come in, bring its chromatid, and then you're going to have 1, 2, 3 instead of 1, 2. And the same thing will happen over here. The sperm will come in and fertilize this egg, but there's nothing there. There's only 1 chromatid. This is going to be called a monosomy. So you have just 1 chromatid. I will tell you, most monosomies are deadly, but there are some monosomies that exist. And the same thing will happen over here. You'll get a monosomy. So you'll have a half chance for a trisomy or a half chance for a monosomy in this case. Bring in their single 1. All right, so let's look at an example of this. Let's go to Google Images. Let's go to a trisomy karyotype. All right, check it out. That's trisomy 18. There are 3 chromosomes there instead of 2. Well, that's a better picture because it's not replicated yet. Trisomy, and then let's see, monosomy karyotype. Oh, there it is. Okay, there's one. Chromosome number 7, the monosomy exists right there. So I'll show you what these people will look like in a few minutes. All right, now let's go down to nondisjunction in meiosis 2. So meiosis 1 happens completely normal. So we'll start here after interphase where the chromosomes have been replicated. So we have our tetrad like that. They're going to divide nicely down the middle as they should. And we'll put the pink side over here and the blue side over here. All right, so that's not the problem. Let's go ahead and move into our meiosis 2. Let's see. Draw our 4 resulting gametes. All right, so over here, this is not going to come apart. This chromosome, the sister chromatids are going to stick together. So over here, you're going to get this replicated X when it should just be a single line. So when the sperm comes in to fertilize this egg and he brings in his copy, you end up with a trisomy. And over here, it got nothing. So when the sperm would come in to fertilize this egg, you would get something called a monosomy. And then over here, you don't have to have nondisjunction at all. You can just have a regular separation. So it just depends on at what level of meiosis this happens. The trisomies and the monosomies will occur as a result of nondisjunction, the chromosomes not coming apart.